Hi. My name's Pete Gamache. I'm head of engineering at a little startup called AppQs in Boston, right near Fenway Park. I've spent the last 6 months learning how to deploy Elixir in the context of a long-lived Erlang cluster, and I'm here today to give the talk that I wish I had heard back then. How many of you want to be using Elixir in production? Sweet, I'm going to throw a small amount of cold water on you. All right, I'm gonna start at the end. The summary of this talk, so you can leave if you want. Elixir and Erlang, absolutely a rock-solid platform. I don't think anyone in this room is going to debate that point. It's a good starting point for building many different types of applications. Erlang excels at traditional long-lived server clusters. And I'm going to go into more detail about what makes it traditional rather than perhaps a more modern approach, and why Erlang's so good at it. Modern deployment practices do not optimize for long-lived clusters. I think most people here know this. It's all about servers that poof into existence and bamf right back out when you're done with them. And deploying Elixir, there's going to be pain. You're going to hurt. I'm not going to sugarcoat this for you. But if you've chosen the platform for the right reasons, you can still get away with it and come out ahead. So at this point, I'm going to step back a little bit and let's talk about what makes an ideal platform. So I came up with a little list of platform desirables. None of these are terribly controversial. Horizontal scalability, essentially being able to throw money at a problem of computing and just add more servers to the fray. Very desirable. The alternative to that is you make bigger servers and eventually you hit a wall. You can't jam any more RAM in, you can't jam any more storage or CPU. Fault tolerance, everyone likes it when their big distributed system does not completely fall apart when one small element of it does. Zero downtime upgrades and rollbacks. Certainly those of you coming from the Ruby community, it was a hot topic there a few years ago. It's a hot topic everywhere. Everyone wants to be able to upgrade to the next version without downtime. And if you can do that, everyone double wants to be able to do it in a rollback, because in a rollback, your hair is on fire, and there's a time limit. Stability and performance are just table stakes. I mean, very few people are willing to use a janky platform for an internet service. And finally, this last one is for us humans, ease of administration and maintenance. A lot of things are theoretically possible if you want to climb into the Turing tar pit. I'd prefer to focus on what I can get done today-ish. So let's talk about an average platform. And I'm using the word average not as a disparagement, but just to say, kind of the median these days. An average platform on the internet is very good. If you go to websites and the websites return 200 OK and serve you what you want, that means things are working. So let's talk about what works. Now I arbitrarily labeled this Devops 2010. You have fleets of servers. They're stateless. They don't care about any of the servers around them. They're getting work either, depending on what sort of workloads they're serving, they're in a load balancing pool, or perhaps they are taking work off the same shared queue. And since they are incredibly stateless, all message passing to other services, other microservices, that happens externally. All state is held externally. These servers are just disposable. So in this system, when you want to upgrade, you've written some new code, you want to deploy it, great. You start up a bunch of new servers running that code. You add them to the pool. You remove the old servers, and if you want to do it right, you have to kind of like starve them for input for a little bit, do the connection draining thing, let them do all the work that they have currently slated, and then who cares what happens to the old servers? You take them out of the pool, and they're done. There's a slight enhancement to this that alternately is called hot-cold deployment or blue-green deployment. That's when you pretty much keep two sets of servers running. Only one of them is serving traffic at a given time. But the advantage is you don't have the overhead of spinning up these services. They're already there. You can deploy to them fairly quickly. And if you need to roll back, you basically just flip the switch to point to the old ones rather than the new ones, and you're out of trouble. I think a lot of us have done that here. Now, there's a lot of moving parts to the system that I just described. You have to have good scriptability over your provisioning. I mean, this sort of implies that you're using virtualized servers just in order to even try doing this. If you're doing this on hardware, you're probably virtualizing it and running VMs on that. You need good control of the load balancer. You need either very good intuition or some good insight into the connection draining and who's still working on what. So it's achievable, but it is a bit of a burden. Now I'm going to skip to Devops 2016. This is the future. Pretty much all of Devops 2010 still applies. Containerization is sort of like an 8-in-1 multi-tool. It's good for encapsulation of services. It's good for distribution of services. It's good for security. It's good for this. It's good for that. All right, great. Heavily automated. That is one of the themes of Devops 2016 is, in order to use all of these super spiffy tools, there is a lot of tooling that you need to make sure all of the hoses are connected and all of the wires are plugged in, or else it, doesn't work. There's also some far out ideas which are beginning to take hold. I don't know exactly the right way to put it. Resource pools that can execute stuff. So being able to just have a bunch of servers act as an amorphous blob of compute, storage, and RAM, and then assigning tasks to work on that. AWS Lambda is a great example. I don't know if they're using Mesos under the hood at Lambda. If not, they had to write something that does substantially the same thing. But it's pretty neat to be able to have a pool of resources and not have individual computations tied to particular servers at any given time. So does the average platform actually get there? Horizontal scalability, fault tolerance, check. They do it, can't deny it. Zero downtime upgrades and rollbacks, yeah, they're mostly there. It takes some dancing around, like I mentioned, but you get there. Stability and performance, obviously, we all use the internet. It remains there for us to use. It's not all written in Erlang and Elixir. Ease of maintenance, though, I am not so sure that we got there. So now let's turn our eyes to Erlang, the Erlang platform, not Erlang the language. Things that Erlang does very well. Extreme fault tolerance was one of the goals of the platform from the very beginning. Telephone switches are not allowed to go down ever. So you achieve this fault tolerance through a very smart supervision API that's baked right into the core language. It's very simple to scale an Erlang cluster into the dozens of nodes. And this is an actual cluster. Every machine knows about every other machine in this cluster. So it's not the kind of thing that you can practically throw 5,000 machines at, cluster them all together, and set them loose on a problem, because your network is just going to melt due to the crosstalk. But for a couple of dozen servers doing roughly the same thing, you're good. Zero downtime upgrades and rollbacks. We know Erlang has them, and they're fast. They are really fast. Once you've built the release, the upgrade is typically just a thumbs up or thumbs down. You made it or you didn't. Stability and performance, we know it's there. Now, there's one thing missing, and that is what Elixir helps with. Creature comforts, ease of administration, ease of maintenance, ease of writing code on the damn platform to begin with. I love Erlang the platform. I think Erlang the language looks like Prolog and ML got into a car crash in the 80s sometime. So I'm kind of happy to leave that part of it alone. So Erlang clustering, it's again, been around a while. There aren't a whole lot of other systems that do this, but it is about making multiple machines all work together on a single workload in an internally stateful way. The machines in this cluster know about each other. You can do neat things with this. OTP apps are a really nice way of encapsulating pieces of functionality. People would call that microservices. It's certainly like a microservice if you squint hard enough. An Erlang cluster is basically a little Mesos in a box. If you don't need massive computation or scale, you can really set something up very quickly to do this sort of thing. And because you can cluster so easily, you can postpone perhaps sharding your workloads onto different servers or different clusters. You can postpone bringing in outboard message brokers in, whether they be HTTP services, whether you're putting things onto a queue or a stream. You can take care of that, everything in the box. Now, this does not look like DevOps 2010 at all, but it achieves a lot of the things that DevOps 2016 is trying to do with, I'm going to call them, lesser platforms. I decided if I'm going to buy into this platform, I want to really buy into the platform. Certainly, you can use Erlang any way you want, and you're going to get some advantages out of it. I wanted more. Startups love time to market advantages, and everything I've just described. Really easy to set up a cluster, really easy to run multiple microservices on it. You don't need to set up external queues or streams or stuff like that. That gets you to the market faster. Now, don't use it just because it is the shiny new thing. If you're bringing this into your company, you're putting money on the line, and it is worth evaluating exactly what you're going to gain and where you're actually going to pay the toll. If Erlang and Elixir have features that will shave huge amounts of programming time out of your project, it may well be worth it to sit through the occasional pain of deployment. It works when it works, and that's really nice. But I'm not going to pull the wool over your eyes. It is going to blow up in your face sometimes. Also, if things like maintaining connections, if dropping connections isn't a big deal, consider DevOps 2016 and the Erlang platform. Because it will work fine, but you are leaving certain features of the Erlang platform on the table. Ultimately, nothing is free. Once you get into the hundreds of servers, you are going to need to make some tough decisions about, okay, what are we going to extract into other services? You won't be able to automatically operate at big scale, but small to medium scale, it's got you covered. So deployment is, roughly speaking, it's the sum of your tools and your network topology. And topology there's a lot to say about it. I am not the most qualified person in the world, so I'm just going to hang back and let other people do it. I'm just going to say, for the purposes of this discussion, let's assume you have two of everything. Because that makes it a lot more of an interesting discussion when we're talking about clustering. So let's talk about tools then, if I'm not going to talk about topology. This is what Erlang gives you. This is an excerpt from Learn You Some Erlang. You may notice I have skipped steps 5 through 21. They're all like, copy this file to this place and edit this, and then run this command, and then run this command. You might want to write a few scripts to automate this. Yeah, you do. And it sounds like the vast majority of you who are making releases are using our friend, the Elixir Release Manager. This handles most of steps 1 through 25. There are a few of them it doesn't. I think one of the steps is make sure your code doesn't have bugs and crap like that. But this takes care of generating an Erlang release from your code. And what that is basically a package that contains everything that your application needs to run, including Erlang itself. You just put it in place. It gives you a command that will start and stop and restart and attach a console, run RPC calls. But then you got to put them on servers. And this is the part that I found to be a little bit lacking when I first started to investigate how am I going to get away with this. But then I found a nice tool. It's called edeliver. Anyone here use it? Cool. So it's based on deliver, which is it's a deploy tool that's written in Bash. You can kind of consider it similarly to something like Capistrano, except the main difference is when Capistrano has 15 tasks to accomplish, you SSH into your server 15 times in a row, whereas deliver will make a Bash script that is 15 steps long, transfer it to the server, then just execute it. I'm kind of agnostic to that part of the tool. It's just that these fine people at Bold Poker, an online poker firm in Berlin, decided to write an Erlang and Elixir delivery service on top of Deliver. Works with rebar, mix, relx, exrm, basically all of the tools that we're used to using to generate these releases and version our code and all of that, no problem. It handles building the code, deploying the code, versioning, upgrades, downgrades. There are some newer features where it claims to handle database migrations as well. I'm not as familiar with those, so I won't speak as much about them, but I'm going to talk about the general core of the functionality. It's pretty easy to use. You add it as a dependency in mix.exs, as you might expect. There's a config file that you fill out. I will show an example. You set up your servers with the correct logins and directories, config files where they need to be, VM args where they need to be. You use git tags to mark your mix.exs version. And this is not necessarily mandatory, but I'm going to strongly recommend you do. And then you run mix tasks, make money, do it. Okay, so here we have mix.exs. I added edeliver to not only the deps section, but also the application section. It runs a little service which can be pinged by edeliver to tell you what version of your code you're running. It's pretty convenient. Next up is the deliver config file. It's a bash file, so real easy to understand. The important parts are app, you set it to your app name, build host, build user, and build at, that's your build server. Staging host, staging user, test at, there's your staging, production host, production user, deliver to, there's your production setup. These staging hosts and production hosts, those can be space-separated lists of host names or IPs, so you don't think you have to do it on one server, you can use more. For this example, I just set everything up on localhost because, I own it. I have mixenv and I have link VM args. Mixenv is a hack that I put in there in order to make the link VM args work. Does everyone know what the VM args are? Actually, you know what? I talk about it in like 2 slides. I'll shut up. This is a little bit further down the deliver config. This pre-Erlang get and update deps, that's a hook that deliver provides, or edeliver I should say, provides, that we can add some code. So in this case, I copy all of the config files into the config directory. My service is structured so that if you don't have dev secret exs, staging secret exs, prod secret exs, all there, it won't compile. So I like it when it compiles. Git checkout remote, I'm going to talk about that later. It becomes important during the gotchas section. And there is a gotchas section. Directories are pretty simple. Build at, test at, deliver to. Don't even create them. Just make sure that the permissions for them to be automatically created by your build, test, and deploy users, just make sure they have the permissions to do it. Configs go in config at, VM args file. They go on each individual server, and this is a subtle difference that the docs don't make blazingly clear. The configs live on your build server. VM args live on the individual servers on which you're deploying. And this is important because that is how the servers that's how they know their own name. A really quick clustering how-to. There are params and VM args. These are the arguments you start the Erlang VM with. You can keep them in a file and they will get automatically applied as part of your release. There is also a config that you put in your usual config.exs, which it has sync nodes mandatory or sync nodes optional. There's a lot more parameters that you can play with, and I give the URL of the documentation that describes them much, much better than I will. But here's a practical example. Up top, I set the name of the node. There can only be one node with this name in the Erlang cluster. I set the cookie. This is for distributed Erlang. It's a shared secret, so protect it with your life. And then in prod.exs, you'll notice I have sync nodes optional. I use optional because when one of my nodes goes down, I don't want the others to follow it deliberately. So I have 2 server nodes. There we go. Now, versioning. edeliver has introduced some new features around both versioning and auto-versioning. Use them at your own risk. I would not recommend it. Every time I've tried, there has been a small explosion. No one was hurt, but I stick to this. Every time I commit a change where the version in mix.exs changes, I make a git tag with that version, exactly 0.0.1, not v001, not version 001, just exactly the semver that you're putting in mix.exs. It just works better that way. Maybe in a few months, we will have more choices. I didn't write the talk then. So we're going to take it out for a spin. It's pretty easy stuff. One of the reasons that I was drawn to it, it's really simple to use. So let's build our first release. We type this magical incantation, mix edeliver build release, and we tell it what version that we want to release. It does that. It does some stuff. You can see it. It pushes. Oh, I should mention this. This is an important thing. This uses your Git repository. This does not use, for instance, the GitHub main repo. This uses the repository that is on your computer. So you actually don't have to push your commits or push your tags. You can just keep them local and push them when you're super sure of them. So pushes commits to Gamache at localhost is my build host in this case. It does the needful, generates a release, and it copies it back to my local computer. So when we want to deploy it, mix edeliver deploy release to production. I give it the version number I want to deploy, and since this is the very first time I say start deploy because it wasn't running before and I want it to start. It uploads the release that we have in our local releases, it extracts it, it starts it. That's that. And here is a little example. We go into our production deploy directory. This is what an unpacked release looks like. And bin my app, change the name for your application. If you ping it, it should pong. We started it, and we see that it does. Now is the fun stuff. Hot upgrades, that is why we all showed up here today. Some of us took trains and planes to talk about hot upgrades, so get comfortable. I'm going to bump a version number, 002. It's one more than one. I git commit, I git tag, mix edeliver, build upgrade from 001 to 002. Very straightforward command, once again. And in this lovely ideal case, it just worked. All of a sudden, our application has been hot upgraded to 002. Now, the hot upgrade process is pretty neat. What it's actually doing behind the scenes is there are a set of what are called app-ups, and they're scripts that say for each OTP application, this is how to transfer or to transform the old style state into the new style state. And then a rel-up, release upgrade, collects all those app-ups into one. And this is the script of what happens when you are actually performing an upgrade. edeliver will make the default app-ups and rel-ups for you. So essentially, I'm just saying nothing needs to change. I haven't changed the shape of my data anywhere because I didn't, one, I didn't have to, and two, it's kind of an involved thing when you have to crack open an app-up file, and I would prefer to just avoid that. And then, what actually happens when the app-ups are all executed, we start a whole bunch of new code with the new versions, and they receive all the messages that you would send to those processes in the old version. The old version stops getting input, but it's allowed to continue executing. Anything that's 2 versions old, which has probably just been sitting there for hours or days or weeks, gets killed. So basically, unless you do 2 of these upgrades in extremely rapid succession, the connection draining is just taken care of by Erlang. You didn't have to write any code to do it. Love that. So deploying the hot upgrade, it is just as easy. Deploy upgrade to production. You say the version, and it just does it. Here is just a little magical demonstration. I added a little function to myapp.x. It will just give the version of this application. It's a lovely little code snippet. I use that all the time. So I open a remote console when it's running 002, and I can see my app.version, it spits out 002. When I say upgrade occurs, I opened another terminal window and I made an upgrade to 003 and I deployed it, and I say my app.version, and there I am, 003. I didn't have to disconnect. This extends to web connections, WebSocket connections. You don't drop connections. It's really nice. But it does not always work. Works a lot, doesn't always work. Sometimes it's a matter of some of the software you're using has changed its shape, the shape of its state rather, and you need to take that into account manually. Sometimes certain packages are just not in a position to be hot upgraded. Cowboy is a good example. It is very difficult to not drop connections when the thing holding those connections is what you're trying to kill and restart. So you don't. So keep your Cowboy upgrades infrequent, and I think you'll probably be fine. And sometimes, you know what? Sometimes it just feels like it's not in the cards. I am not a scientist about this stuff. I am, I've just been in the trenches for a little bit, and I've seen good men die. And I don't have great explanations for it, but I do have some ways that we can make it around the mines in the field. If you can't upgrade hot, then rolling upgrades are your best fallback. Here we are in Devops 2010. You pull the servers out of the pool, you restart them, you put them back in the pool. Depending on how much you care about people and how your app is structured, you might be able to just not take them out of the pool and just restart them anyway. It's much easier to do rolling upgrades because rolling upgrades will feature a non-trivial period of time where you have multiple versions of your software running at the same time. And so the best practices kind of follow, it's very similar to how to do a gentle database migration. Don't immediately assume that the new column is there and the old column is gone. Write your code in sort of a transitional way. Takes a little bit longer. There's a little bit of temporary technical debt, but it makes the whole process a whole lot error-prone. Rolling upgrade, you build a release, you deploy the release probably without start deploy. If you give it start deploy, it will restart all of the servers at the same time. Probably don't want that. You might want it, but you probably don't. And then on each server, you execute that command. Just cd to your release directory and appname.sh restart. Rollbacks, super easy. They are just upgrades. If you could upgrade from A to B, you can roll back from B to A. This is immensely convenient because upgrades take place generally in well under a second. So when you see that you have just deployed the worst code in the company's history, everything is going haywire and customers are at your door with pitchforks and torches, all you do is you upgrade to a lower version number for which you've already built a upgrade release, and it does what it has to do. Now, I mentioned migrations and the fact that edeliver now supports them. I've never used this feature. Also, on the Plataforma Tech blog about a month ago, there was a nice article about how to stick a little bit of code into your project so that you can run your database migrations from the release. Honestly, what I do, because my build server is in the same network as my production servers, I just log into the build server and run the migration like I'd run the migration at my desk. It works. You can choose any one of these three. Now's the fun part. I ran into a lot of problems over the last 6 months. I was surprised at some of them. I was genuinely surprised. Here coming up is one of the least surprising ones. Ulimit. How many people have dealt with Ulimits before? Unix does this wonderful thing where in the Unix philosophy, everything is a file. A network connection is a file. And Unix made the decision early on that if too many files are being used, for some reason this implies there is a problem on the machine, so they limit the number of files. This can screw up your day in a number of different ways, but in Erlang, which is pretty much known for the number of connections that you can keep open concurrently. It's a real pain in the butt. So you need to set Ulimit very high. I don't describe how to do that because it's operating system specific. So read the man pages and set it very, very high. And then in your VM args, there is an environment variable called Erl max ports, which can be used, well, it sets the maximum network concurrency of an Erlang node. Set that very high once you've unlimited your Ulimit. Exceptions. Exceptions, when thrown too quickly, can cause death in parts of your application. And this is taken care of by a supervision tree generally. But depending on what part of your application is throwing exceptions very, very quickly, and depending on how dumb you were when you set up or did not set up supervision trees and you're just kind of falling back on what you're given, maybe your entire app is going to die. I'm not going to say this happened. So here's a crap solution, but it's not as bad as the one that I'm about to tell you. In VM args, there is a -heart parameter that you can give. And what this does is it sets up a heartbeat watcher process separate from your Erlang process. And if Erlang dies, if the whole VM packs up and flies south, the heartbeat monitor will restart it. It says right there in the VM args file, use this with caution, so do that. When you're ready to throw caution to the wind, there's solution number 2, and I like to call this the brick on the pedal pattern. You can just start a release arbitrarily number of times. It won't start it again. It'll say, hey, I'm already started. So yeah, if you cron that every minute or so, you end up with pretty good coverage. I haven't calculated precisely how many 9s that is. Yeah, and at the bottom of the slide is the less glib solution. Fix your code. That's really the only way you can avoid this. You shouldn't be throwing exceptions all that quickly. Here's something that I didn't really know could happen on Beam. In pure Elixir code, I was managing to segfault. Maybe it was cosmic rays. I don't have good answers for you. But the same instructions as the previous slide. You just need to make it not do that. I'm not concerned how you do it. Make it stop. Here is an edeliver related gotcha. Sometimes you will have a release stick around for a little bit longer than you want it to. For instance, if I make an upgrade from X to Z, and I put it on the server, and then I decide, you know what? I think I actually needed the upgrade from Y to Z. I forgot that I deployed Y yesterday. It might not ever actually unpack that tar GZ. It will transfer it to the server, and then it'll be like, oh, it's already unpacked. I'm just going to use that. The solution is to just blast the directory. Not complicated, but I ran into it a couple of times. This is one for production deployment that I also did not expect. Sometimes I was seeing, or rather, when I went into production, started testing, I was seeing these 400s come back when trying to use the WebSocket feature. Now, I tested this extensively on my own machine, tests all around it, and I was getting these 400s, and I couldn't find them in the server logs. Now, that is the clue. I didn't find them in the server logs. So I was hitting a wall before I even got there. What it turns out is that in many cases, you need to be very specific with whatever web proxy or load balancer you're using that you want to support WebSockets. On Amazon Elastic Load Balancer, which is how I'm deploying in production, they give 2 sets of roughly identical settings. HTTP, HTTPS, those don't work with WebSockets, but if you use TCP on port 80 and or TCP on whatever port you want and SSL on whatever port you're using, it will work exactly like HTTP and HTTPS, except it will do WebSockets. I don't even know why they give HTTP and HTTPS, considering they are somewhat crippled. And TCP and SSL seem to just work just as well. Nginx, there are a couple of proxy headers that you need to send along. that are not in most of the example web proxying in Nginx tutorials on the web. Those are the ones. I'll have to excuse the old style screenshot on this one. Sometimes you can run into Git problems. I ran into this is from Monday. This is a late addition to my talk. What was happening is that in between two versions, it would build one version, and the process of building it would mutate mix.lock. And then Git would say, oh, wait, you have changes. You totally cannot check out anything until you stash your changes. That pissed me off and was stupid. Didn't know how to solve it, so the first thing I did is I went into the source code for edeliver, and I grepped for the phrase checking out. And I found it. This is the piece of code that was blowing up. Now I noticed git checkout remote is the name of the function. I said, well, what if I could just put that in my config file? That seems really simple. Could it actually work? It worked. So you'll notice I've updated checking out revision the rad way, because we're doing better than we used to do, and you'll see the second line from the bottom, git stash, is going to take care of that mix.lock file that I do not care about. And then it works. You see it checking out 002 the rad way, and then going along its merry way and doing what I just told it to do. So we're near the end. I'm going to give you another summary. In my opinion, Elixir and Erlang deployment, it shouldn't look like what you do on lesser platforms. If you want to take advantage of the full platform, you're going to have to leave some of the current best practices in DevOps aside for now. Edeliver gets this right so much of the time. I want to say 90%, and I think that's about right. I mean, let's see, I've made 84 releases of my production API in the last few months. And how many gotcha slides do you see? 6, 7, and a couple of them happened twice. So yeah, I'm just gonna say 90% of the time you're gonna be okay. But even when it does blow up, the amount of time you spend on that may well be far less time than you would have spent on something else. In my case, I'm using Phoenix channels very heavily. And if I had to write that in another system, it would have taken weeks to get that right. In Elixir, with Phoenix channels, I think I spent maybe 2 hours on that part of the code, and I've barely touched it since. So for me, I think this was a good bargain. And the final takeaway is that 2016 is very early in Elixir and in the Elixir deployment timeline. I mean, the book is still being written on this stuff. So the problems that you're going to have today might not be there 6 months from now. Hopefully, most of them will have vanished a year from now. That's what I got. Questions? Sure. The question is, have I considered using Ansible along with this? I don't go into that in this talk, but my servers are provisioned with Vagrant and Puppet. I chose that rather than Ansible because I don't know my ass from a hole in the ground when DevOps is concerned, and I managed to make something work with Puppet. When I say edeliver is under active development, is that daily, weekly, monthly? I would say daily to weekly. Yeah, it's moving, and I don't want to call it a moving target because they haven't made breaking changes, but they are actively working on it, and there is opportunity for the rest of us to pitch in. I may end up kicking some patches back to the project. Yes, so the question is, doesn't this run afoul of the servers as cattle metaphor because I'm treating my servers as pets? I am treating my servers as pets. I am. Which is not to say I can't banish one of the pets from my cluster if I need to, or bring new ones in, but I am not intending to immediately bring them to the slaughter when I'm done with them.
Maybe one more?
Sure. One more?
Do you have any comments on umbrella apps and deployment?
I do not have any comments on umbrella apps and deployment because I have no experience. If I got a couple minutes, I could just talk. I have no expertise.
You've had 40 minutes to talk.
Well, thank you.
Thanks, Pete.